So this video is about creating functions out of problems. So what that means is we need to have something like f of x equals, and then we can only have stuff in here. So like some number with x plus another number with x cubed, but it can only be x's. We cannot have this. This is a no, because it's f of x, not f of x comma h. So we want just plain old f of x here. So let's try our problem. A rectangular storage container with an open top, so that means the top is completely open. We don't want to include it. It looks like that. So we have an inside. The length of the base is twice its width. So the length of the base, so that would be 2x, and that would be x. It's twice its base. Material for the base costs $10 per square meter. Material for the sides costs $6. So we should write these down. So the cost for the base is $10 per square meter, and the cost for the sides is $6 per square meter. What that means is we need to find a surface area. This is what they want, is a surface area to make this box. We got an inside line here. That looks a little better. All right. So express the cost of the material as a function of the width and the base. So if you look at it, we're going to make a cost function. That's what it wants in terms of x. And that would be the cost of the base plus the cost of sides. Now that means that we need to find the cost of the base and we need to find the cost of the sides, and then we can plug them in. So let's look at first the base. I'm going to make a base here, and I'm going to extend that line down. And so the base is an area. We want the area of the base, and that is always length times width. So this would be 2x times x, which is 2x squared. So now the cost of the base would be that area times its cost. So it's always value times amount, right? So we're going to have 2x square meters, and it's $10 per square meter, so that would be the cost of our base. So that turns into 20x. Everything is good so far. Now what we have to do is do the sides, and we're missing a variable on the sides, so let's call that variable h. Now to make these sides, this one, this one, this one, and then the front, right? There's a little trick you can use. And so what we're going to do is take that perimeter. That's x in the back. So you're going to look at the base itself. That's x, x, 2x, and 2x. And what we're going to do is basically stretch this up, this perimeter here, this nice outside perimeter, which is actually 2x plus 2x plus x plus x. That's 6x. So that perimeter is 6x. And we're going to take it and we're going to basically stretch it up. And so if you stretch that up, it creates the sides. It looks like this. So we have our perimeter here, our 2x, 2x, x, and x. So that whole thing is 6x. And then we're going to stretch it up like this. And so as it stretches up, you can see it's creating the sides until we get to the top. And so it's 6x times whatever that is. It's that 6x being stretched to make the h. So it becomes 6x times h. So you can see the 6x being stacked. So that's one 6x, that's two 6x's, three 6x's, so on and so on. We're going to have h 6x's. So that would be 6x times 1, 6x times 2, 6x times 3, 6x times 4, and so on until we make the entire side of the box. So for the area of the base, of the sides, we're going to get 6x times h. So all it is that perimeter times h. So if you find the perimeter of the base, you multiply it by the height, it creates the sides. You can just physically see it changing. So this would become 6x times its cost, which is $6. And there we go. Now we have our total cost. So this is 36x. and then we got to throw in that h over there, h. And so here's our problem. You can't have a cost function with h. So what we need is a secondary equation. And that's always that little piece of information they're giving you. So a rectangular storage container with an open top has a volume. Well, volume of a box is length times width times height. And so if we plug that in, that would be 2x times x times h. And that volume is 10. And so you now see we have a second equation that involves x and h. And so if we solve for h, we get 5 over x squared. We now have something that we can plug back in. So to make our function, we just had to create a secondary equation, use it to substitute for that one variable we don't want. So whatever you're trying to get rid of, that is the letter you solve for. So if you want to get rid of h, you solve for h. And that allows us to get rid of the h. And now we just simplify a little bit. This is 20x plus, and then 36 times 5. 180 over x, and there we go. Now we have a cost function. And yeah, you could do common denominators, and we would get c of x equals 20x squared plus 180 over x. That is an alternate equation, but we need to just make sure that our function is in terms of one variable. All right, that's the most famous box problem. All right, we're also going to have triangles. So it says express the area of a triangle as a function of its base. And this is an equilateral triangle, very important. So equilateral means all sides are the same. And so if this side at the base is x, then we can split that into 1/2 x and 1/2 x. Now, if you remember area of a triangle, that's what we're looking for. So that's where you want to start. Just like on the previous problem, it said to express the cost. So we needed a cost function. This one is express the area. So area is 1/2 base times height. And so we already know our base here is x. And so now to get rid of the h, we do the exact same thing. We need a secondary equation. And that's where our little work that we have here called a squared plus b squared equals c squared will give us a secondary equation. Anytime you see a right triangle, you can use your trig ratios, and you can also use a squared plus b squared equals c squared. The reason we're not using the trig is we don't want to introduce another variable. We don't want to introduce a third variable of theta. So if I put a theta in there, that's now a third variable. Not a good idea. All right, so we use a squared plus b squared equals c squared, and we plug it all in. So remember, c is the hypotenuse. So b here is h squared, and c is our x squared. It's always the one that's opposite the 90. That's our c. So this guy right here is our c. All right, now you can see that we have our h that we can solve for. So this is x squared over 4 plus h squared equals x squared. And so subtracting that, we get h squared equals, and then that's 4/4. Take away 1/4. So 4/4 take away 1/4 is 3/4. And then square root. So our h is equal to the rad 3 over 2 x. And that should sound familiar to us. You could also have used our 30, 60, 90. So we know that that's 60 and that's 30. So you could use the rules for 30, 60, 90 as well. So a equals 1/2 x. Let's put that back in blue so we know what we're plugging in. So a equals 1/2 x rad 3 over 2x. And so simplifying that, we can now write it as a function because we have just one variable. This is rad 3 over 4 x squared. And so now you have a formula to find the area of a equilateral triangle based on just one variable. And we're going to be able to use these now as our graphs and be able to graph them and figure out. So we know this is a parabola. So all the areas are a parabola.